Hi and welcome. My name is Megan Smith. I am a certified orthotist and the Director of Clinical Research for Surestep. Today we're going to be talking about the development of gait, getting back to the basics. So this is the first course in a series of 5. Be sure to check our website for the additional courses. This is a painting that Vincent van Gogh did in 1890. The painting is titled First Steps. So this depicts a father and a mother out in the field with their young child taking their first steps. And I think this is powerful in that it shows that for a long time, first steps have been a very big milestone for our kids. We celebrate it, we get excited for it, but it's not as if a child just gets up, one day and decides to walk, and these first steps are not the end game to gait development. So while I think it's a very exciting thing to celebrate, we need to make sure that we're paying attention to what happens beforehand and after these first steps. So the objectives of today's course are to go through the building blocks of gait development, talk about the development of postural control and spatial organization, understand toddler gait characteristics and how they develop, talk about how, when, and why we want to address those abnormal postures and positions and gait patterns, and understand why Surestep works so well and helps to facilitate those gait patterns, and the key factors as we evaluate and refer for orthotic solutions and therapy goals. At the end of this course, there will also be a 10-question quiz, so be sure to pay attention. So these are the building blocks of gait development, and what we see here is a pyramid of different inputs that we need in order to get a positive gait development. The bottom row is made up of what we're given, so bony structure, muscle tone, ligaments, tendons, and fascia, which is our Tensegrity System, and then our Somatosensory System. What we do with those through practice, variability, and use history is develop postural control and temporal spatial organization. From those, we get gait development. Now, as we talk about this, we're going to move up the pyramid, but we can also relay this down the pyramid. Once a child's walking, we can take a look at how they control their posture, what their weight lines are, have they had proper practice, variability, and use history, and then also taking a look at that bottom row and what do those structures look like. And we can change either going up or down this pyramid. So we'll first start out talking about the bottom row of these building blocks of gait development. Due to the time constraints on this course, we're going to briefly discuss the bottom row and then really take time to talk about the top section of this. And the bottom row is what will be coming, or what to look for on the website for future or for additional courses. So first focus on bony structure, muscle tone, ligaments, tendons, and fascia, or the Tensegrity System, and the Somatosensory System. Bony structure consists of joint development, normal natural joint development, bone ossification, and Wolff's Law. So we go from approximately 300 bones as infants to 206 in adults, and this happens through ossification, which is the hardening of the bones. An example of this, if you take a look at this drawing of an adult foot and a toddler foot, you can see that there are many more bones that are solidified in an adult foot versus a toddler foot, especially there in that medial column, which is really important in the development of the arch and as we go forward. And Wolff's Law states that bone growth is influenced by forces. So whether that is muscle pull or gravity, the bones grow based off of those forces. Muscle tone can be described as a bell curve. So we have kind of our normal or typical muscle tone in the middle, and then on the far sides we have our very low tone kids and our very high tone kids. And those are typically the kiddos that we treat. So we see either really low tone or really high tone kids, and not necessarily those kids that fall in the middle of tone. But I think it's important that as we talk to each other and to our families, that we all understand that tone does not equal strength. I know I've come out of many castings of kids with Down syndrome, and I'm sweating. So underneath that tone, that laxity, they're actually very, very strong when they're put in a good position, and vice versa. So underlying the tone and spasticity of a child with cerebral palsy, that muscle is actually weak. So I think it's important that we educate our parents and kind of on the same page of letting them know that tone does not equal strength. Okay, so the Tensegrity System, I think there's still a lot that we don't quite know about the Tensegrity System yet. We're learning more and more every day, but it has a lot of good implications for where we could go for orthotic and therapy treatments. Tensegrity systems are made up of compressive rods and tension wires. And now on the bottom left, you can see an architectural structure of compressive rods and the tension wires. And you can see that none of the rods are actually touching each other. They're all being held up by these tension wires. And our bodies work the same way. So from an anatomical level all the way up to a macroscopic level, we are a tensegrity system with our bones acting as the compressive rods and our ligaments, tendons, and fascia as the tension wires. Somatosensory system is made up of proprioception, joint receptors, mechanoreceptors, and really just kind of help us understand where we are in space, what's the relationship of my joints to themselves. We get a lot of sensory input through that. So the sensory system and the somatosensory system are really important as well in developing gait and postural control. Okay, so now that we've talked about that bottom row, next we're going to dive into the development of postural control and how we learn to control our weight lines. So two main goals of postural control development are to maintain our balance, which is maintaining our center of gravity within our base of support, and form an interface between perception and action. So if we perceive something that's going to happen, we want to turn that into an action. And we also, as human beings, we have an innate sense to get vertical. We want to get up and get moving. There's a reason why we atrophy when we're laying in bed and not using our muscles, is that we're made to be upright and vertical. So the development of postural control really starts in early infancy. So around 2 months old, we have a relatively immobile spine in the frontal plane and very asymmetrical. By the time we hit 3 months, we start to see kind of this first transition in the development of postural control. Now we have direction-specific postural adjustments. These adjustments are in block, so it's the entire unit moving as one, and they are all feedback. So what we're doing is we're evoking a sensor. These postures are evoked by a sensory mechanism, whether it's a loss of balance or an external perturbation that then evokes the sensory mechanism and this postural adjustment. And then at 4 months old, we start to get a more symmetrical spine in the frontal plane, and then we also start to get some anti-gravity flexion, and this is also helps with self-awareness. So as you can see in this video clip, this baby is reaching for his toes, he's flexing his knees and his hips, he's becoming self-aware of where he is in space. All of these positions, while he's in prone and supine on the floor at this age, he's getting a lot of sensory input from the floor through his pelvis and through his trunk. As he's making those small rotations and those small weight shifts, he's learning to develop some of that postural control. Okay, so at 5 months, we start to get lateral neck flexion and face side weight shift. This is where the head turns towards the face side of the skull, and it leads to face side lateral trunk flexion and helps to load the upper limb on the face side. And we'll see that that's very important in helping to develop movement patterns on the floor. So it's around 6 months that we get the second postural control development transition, which we move more towards adaptive postural control adjustments. So we are still looking at in-block patterns where everything is moving as a single unit, but we're starting to build a repertoire of movement patterns and being able to select from a few of those movement patterns that we've developed. And everything is still direction specific and very variable in the movements. 6 months old is also where we start to see independent sitting. So those two, that transition and that independent sitting, kind of correlate. So at 6 months old, we have anti-gravity lateral neck and trunk flexion. We get skull side weight shift, which leads from rolling from prone to supine. We get a lateral displacement of the center of mass and a shift weight to the ipsilateral side of the pelvis. So So as you can see in this video, as he's rolling, he's flexing that right side and extending his left to help him to roll from prone to supine. He's getting a lot of sensory input again through his pelvis and through his spine from the floor, and as he's learning to shift his weight. And you can see that that flexion and extension pattern is also really important into developing locomotion, whether that be belly crawling or quadruped crawling on the floor. Also at this 6-month range, we get, child starts to sit in a ring sitting position. So the hip position plays a big role in this. So we get abducted hips, which provide a nice wide base of support. It also limits the amount of lateral weight shifts that the child has to do to begin with. Over time, that base of support starts to decrease, and those lateral weight shifts are magnified. So we can see where those movements that we had before of the flexion and extension and those face side and skull side weight shifts are leading up to him being able to go from a prone position and to push himself up into that ring sitting position. And then again, that flexion and extension helped to lead him into this belly crawling. Between 7 and 9 months, we move into a quadruped position. So from a prone lying position, they do the skull side weight shift and flexion of the face side lower limb to get up into onto their hands and knees. And they can also, from that position, push up into sitting, lean forward, and then start to crawl. The third postural control transition is more adaptive. So they're learning to adapt to their environment around them, use the experience and the repertoire that they've built to select proper movement patterns. This 9 to 10 month range is also where we start to see some independent standing. And this transition serves as a preparation for the development of standing and walking. Between 8 and 12 months, we're going to transition into an upright posture. And we do this from that quadruped position, holding on to either hands or to a piece of furniture. Go to kneel, and then shift weight laterally and backwards to load one knee and flex the other and place the foot on the floor. So this is this half kneeling position that we're going to then push up off of into standing. So again, to get upright from that quadruped position, we need to understand how to laterally weight shift and be stable with our center of mass over 1 foot to get up into that standing position. So the next transition comes at between 13 and 14 months. This kind of coincides with 6 weeks of walking experience. We have more anticipatory postural adjustments, so we go from a feedback system to a more feed-forward system, where we're anticipating what's going to happen and making changes prior to it happening versus just reacting to an external perturbation. But at this age, we still have a lot of movement variability, so we're not consistent yet, and we're seeing a lot of different patterns, but that is only building our repertoire through trial and error of different movement patterns. So what do all these movements have in common? They're all patterns, and they're purposeful and necessary practices of center of mass and weight shifts. And the goal of all of these is to learn how to maintain our center of mass within our base of support and be able to shift weight while staying stable, and learning through the motivation that we have to get up and walk, that we can shift our weight, control our balance as we move through all of these transitions. Hundreds of thousands of lateral weight shifts are vital in postural control development. In '98, Adolph did a study where she put sensors inside of infant shoes. And what they did was they calculated the number of times that infant would weight shift or unload that foot. They found that the infants experienced 1,100 weight shifts per waking hour. If we take on average a child that age is going to have 10 waking hours per day, we get 11,000 weight shifts per day. And early standers and pre-walkers are most likely to be up and standing approximately 3 hours a day, in between crawling and feeding and playing on the floor and napping. So we're going to get those 3 hours a day. We have over 3,600 weight shifts per standing hour. So that's a lot of massed practice that these kids are getting. Weight shifting, working on unloading and shifting their weight and maintaining that within their base of support. So this is a couple of videos of a typically developing child who is in the cruising phase. He has moved past cruising with two hands, and now he's cruising with one, being able to hold on to toys and then also to open up and to shift his weight farther laterally, and still maintaining his center of mass within his base of support and feeling comfortable and stable there as he prepares to move on to independent standing and then into walking. Hip development plays a really important role in the development of postural control. So in prone, the abducted hips provide a pelvic anchor, a very wide base of support, and gaining neck and trunk extension. In supine, the flexed hips help with anti-gravity flexion and self-awareness. In sitting, those wide abducted hips help provide a stable base of support in that ring sitting position and frontal plane control. And then in standing, the hip position helps keep the weight on the lateral borders of the feet and provides a nice wide base of support to keep their large head inside their feet. There are multiple sources of sensory input through tactile and mechanoreceptors from the pelvis through rotation and then also through the contact with the floor that help to trigger postural activity. So that wide base of support helps to keep, again, that toddler's big head inside their base of support. Toddlers have very large heads in relation to the rest of their body, so they need that wide base of support to maintain stability. And lateral stability develops before mobility and may actually be the most important factor in infant gait development. Here you can see a video of a kiddo who is not ready to start weight shifting. He's age appropriate, however, his foot and ankle position, his low muscle tone and ligamentous laxity that he doesn't have a very great base of support. He's very unstable on his foot and ankle, and this is what causes him to not be able to shift his weight laterally, even though, again, he's age appropriate. So what we'll start to do with him is address his foot and ankle, give him a pair of SMOs most likely, and if we correct that foot and ankle position, give him some proprioceptive input, allow him to have a more stable base of support, we'll start to get better lateral weight shifts so he can maintain stability as he works on cruising. In this study, they took a look at infants with 1 to 4 months, 9 to 17 months of walking experience. They also looked at children aged 4 to 5 years old and adults. And what they found was that anticipatory postural adjustments, or APAs, were present in the very youngest group and consistent at 4 to 5 years old. So this included a lateral tilt of the pelvis in stance, which allowed that child to unload the opposite limb shortly before swing. So in this same study, they found that those APAs involved both upper and lower parts of the body in the youngest groups, whereas in 4 to 5 years old, it was more in just the pelvis and the lower extremity and that stance leg once they were 4 to 5 years old and into adulthood. So this suggests that our younger kids with less walking experience have a more in block strategy where they're moving their entire body as a unit, versus once we get to 4 to 5 years old, we have a much more articulated strategy, and that articulated operation happens with age and increased walking experience. And postural control will continue to improve with age beyond that 4 to 5 years old. So between 7 and 11 years, we have more adult-like balance strategies and control, a much more articulated strategy of the head and trunk unit, more coordinated timing of the muscles involved in postural control, and integration of reactive and predictive modes of postural control. So no longer just reacting to what's a feedback system, but more of a feed forward, really adapting and changing what they're doing to react to their environment. So goals of postural control are to maintain balance and equilibrium during the initiation and continuation of movement. And posture is what serves as our reference frame for the production of accurate movements. And it is done through coordination, anticipation, and adaptation. So now that we've talked about the development of postural control, we'll spend a little bit of time talking about temporal and spatial organization. So during gait and during any movement, it's necessary to stabilize at least one segment to serve as a reference frame to create positive movements. Okay, so during spatial organization and our choice of a stable reference frame, we have to pick one unit to be that frame of reference. So it could be the foot. We get a lot of sensory input from the ground and through joint receptors at the foot, provides a nice stable base of support as long as it's in good alignment. But during gait, we only have one foot on the ground at a time. So during swing phase, that's not a great choice for a stable base of support or a stable reference frame. It could also be our pelvis. It allows better control of center of gravity. And during gait, the pelvis is always loaded. So it doesn't matter which foot is on the ground, we're always getting that loaded input into the pelvis. And then it could also be the head. It allows more of a clear vision and better vestibular processing. There are two modes of control of mastering degrees of freedom as we move. And we talked about these a little bit when we talked about the development of postural control. But we have in block, which minimizes the degrees of freedom. Everything moves more as a single unit. And then we move to a more articulated strategy where we're mastering those degrees of freedom and controlling independently segments, anatomical segments. So spatial organization can also be ascending. So I'd say if we're standing on a stable support system, that our balance is organized from our feet to our head. And then it can also be descending. So if you're walking on an unstable surface, the balance beam on uneven terrain, it will be from our head to our feet as we're looking down and watching where we're going. So in this study, they took a look at infants with 1 to 11 weeks of walking experience. And what they found was that the pelvis was stabilized efficiently as soon as walking appeared. So even in that 1 week of walking experience, that pelvis was ready to be able to weight shift as they started that independent walking. And so that comes from lots of practice with weight shifts. So starting on the floor, when we talked about the rolling, up into ring sitting, and the crawling, cruising, weight shifting, all of that's really vital to gait development. The shoulder stabilization appeared around the 2nd month of walking experience. And by the 11th month, at the end of the study, there was no preferred head stabilization. So that tells us that we have an ascending progression of control of the upper body segments during locomotion. In this same study, they found that the pelvis was stabilized before foot liftoff. So this suggests a more descending temporal organization of balance from the pelvis to the foot. Now, if we put these two pieces of information together, we have a pelvis-centered organization of balance control during locomotion, and that pelvis is the first stable reference frame for locomotion. So now we've touched on how practice and use history play a role in the development of postural control and of gait, but I want to talk a little bit more about variability and its important role as well. So the first step for a child to develop postural control is to build that repertoire of postural stabilities. So all of that practice that they're getting, the trial and error, the different things that they try, they're building kind of their tool bag of different strategies to choose and pick from. The second step is to learn to select the most appropriate postural strategy. And that requires the ability to anticipate the consequence of a movement in order to maintain their balance and to be efficient. And variability in postural control is needed for positive skill acquisition. There are 5 keys to variability. So variability is a part of normal development in postural control. It's needed for functional skill acquisition. Variability in adaptive postural control facilitates exploration through movement opportunities, perception, and action. A lack of complexity in the postural control may be an early marker of a developmental disability. And enhancing the complexity of variability may lead to functional changes and improvement in motor function. So before we go any further, I want to just show you an example. So we have a Xeno walkway and use the protokinetic software in our labs. And it measures temporal spatial parameters of gait and also center of pressure. So what we see in this picture here through this red line is that what a typical center of pressure line should look like. So starting lateral heel, moving through the midfoot, and then out the big toe. So here's an example of a typical child with 1 week of walking experience. I believe he started walking around 10 months. And what we're looking at is the top picture is the left foot, the bottom is the right, and they're moving from left to right on your screen. The gray lines are individual footfalls, and the red is the average of the center of pressure. So in this first picture with 1 week of walking experience, we can see that he has extreme variability in where his foot comes down. It's definitely a foot flat gait pattern, but his foot is coming down differently each step that he takes. With 3 weeks of walking experience, we still see a lot of variability. It's more consistent in terms of he's got more forward progression of his center of pressure. We don't see that center of pressure kind of bounce back and then forward again. And then at 6 weeks of walking experience, we're starting to see that variability kind of decrease, that standard deviation is decreasing of the between each individual footfall and the average. And then at 5 months of walking experience, we still see some variability, which is to be expected. But as he's continuing to walk and to gain experience, he's learning which motor strategies are best for him and which ones work well. And we're going to start to see that variability continue to decrease. So when we oftentimes describe a child who's learning to walk, we say, they're learning to walk. And that implies that there's experience that plays a big role in the development of gait and in them learning how to walk, that it's not just they get up and go one day. So there are societies where children are not encouraged to explore and to play on the ground, and whether that be due to the home environment, due to, they may live in a place where it's not safe to be on the ground and playing. In those societies, walking on set is typically delayed. So again, that practice that they're getting on the floor and being helped, to learn to move, to control their base of support, to control their center of mass, that's all really, really important in them learning to walk. And walking is dependent on multiple resources, each which must be in a state of readiness in order for that infant to walk. And researchers tend to agree that balance and postural control, as well as muscle strength, are really important factors in walking on set. So these are, again, the pictures from the mat that are from a typically developing 3-year-old child who just significantly pronates. He has muscle tone that's within normal limits. He walked on time. Everything has been on time with him. He's not delayed, but he does have significant pronation. So we can see in these barefoot pictures that he is pronated throughout stance space, so he doesn't supinate, but also that it's really consistent. There's not much variability in his center of pressures. That red line lies right on top of a lot of the gray lines. And same thing with his shoes. We get a little bit more movement in terms of pronation and supination in his shoes, but the variability is still really small. So we put him in a pair of Surestep SMOs, and what we can see from this is we get even more movement in that pronation and supination. So we're allowing more natural motions, but we've also increased the variability. So that red line lies in the middle of all of those gray lines, and we're seeing him actually try different things. So when he's barefoot and in shoes, he really only has one choice for the way his foot can come down. He hasn't had experiencing and being able to come down any other way other than that pronated position and staying in that position all the way through stance phase. So what we're giving him is the ability to start to build that repertoire so he can start to pick and choose. And once he does graduate from wearing the SMOs, if he's got a better foot and ankle position, that he now has balance strategies and strategies to be able to control his center of mass and control his center of pressure. And he's been able to pick the right one for him. But also we're giving him, again, that repertoire, that tool bag to go out and to play on uneven surfaces and be able to pick and choose the right strategy where he's not going to fall. So fluency and variability are indications of skill performance. Fluency is what makes a skill efficient and coordinated, and flexibility or variability is what makes it functional and gives us the ability to adapt. So this is a quote by Adolf, and I really liked it, so it stuck out to me. So what makes skills adaptive and functional is not the ability to reproduce movements consistently, rather it's the ability to modify ongoing movements, select from among a variety of movements to cope with a changeable body in a variable world. And what this basically means is our world that we live in is constantly changing. It's not a static world, it's very dynamic. We have to be able to adapt to everything around us, whether that be uneven terrain, different conditions outside, stepping off of curves, anything like that, that we have to be able to adapt and to change. And if we did not have the ability to adapt and to change, we would not be successful in moving around about in our environment. So in this clip, I had to throw my beloved boilers in here. So boiler up to anybody out there. This is a typical layup. So this guy is out on a fast break. There's no defense. He's doing a layup that he was taught probably when he was 4 or 5 years old. Any basketball coach would be really happy with that form. The thing I want you to notice about this though is there's no defense. There's nobody guarding him. He's wide open. So he can do that skill, the way that he was taught and the way that the textbooks say that we should do that. This next clip, we're going to see a lot of different types of layups. So these are all still technically layups. They're still scoring 2 points. The end result is the same. The big difference between this and that last clip is there's now defense involved. So these guys are having to change their body, change where they're at, shift their center of mass outside their base of supports, work on those weight shifts, having to deal with those external perturbations that they're getting hit with, and being able to control themselves in the air just shows that they've developed this big repertoire of being able to control their center of mass and their postural strategies. And they get this through tons and tons of master practice. So they've been in the gym, probably almost every day their entire lives. They play against their friends, they play open gym, they practice, and that's all them just building this repertoire. So we have got to give our kids that same ability to move and to react to any external perturbations that they may have, to give them, again, this repertoire and this tool bag of postural strategies to be able to control themselves when there is a defense out in the real world. Okay, so now that we've talked about the development of postural control, spatial organization, and the role of variability, we're now going to get into that top section and the development of gait. So when we talk about a typical gait course, we're usually talking about pulling out Perry's definitions and pulling out this diagram and talking about all the different phases of gait. We're still not here yet, right? So our kids were just up and standing, starting to initiate gait. We're not at this point yet where we can start to divide up the gait cycle. So walking in gait is really just maintaining our balance, and it's a compromise between forward propulsion and lateral stability, and that's what keeps us from falling. So our bones, joints, and soft tissue are modeled through use history. And the history of use, or the mass practice, comes from those repetitions that contribute to the sensory motor mapping of the CNS. So starting at infancy with anti-gravity flexion and extension, moving into those weight shifts, practice limb unloading, and then into walking. So in the first 2 years of life, the body weight nearly quadruples, height doubles, and the head circumference increases by 1/3. There are a lot of anatomy and motor changes that happen in those first 2 years. In movement, we go from rolling, sitting, crawling, pulling to stand, cruising, running, jumping, doing stairs. Never in our lives again are we going to see the amount of changes that we see in the first 2 years of life from an anatomy or from a skill point of view. So a toddler gait, they have a very wide base of support, like we talked about before, to help keep their head inside their base of support, help with lateral stabilization. They have a high guard, vertical tibias, poor balance, a lack of propulsion. They have a lack of consistency and high variability, which again, that's what we want to see, is that lack of variability in toddlers. Short step lengths, high cadence. They don't have any reciprocal arm swing at that point in early walking. Flexed hips, flexed knees. We see that they have flat foot contact and everted heels. So some pronation is normal in toddlers, and we do want to see those heels everted some. And they're essentially falling down with every step. So they're landing with their foot flat or toe heel, and their vertical center of gravity acceleration is negative at foot contact. And the cost of walking is actually greater for children than adults, and it starts to become more similar to adults at the age of 6. So there are a couple of phases to toddler gait. In the first 5 months, they're learning to integrate their postural control and what they've learned up to this point into a more dynamic movement. And then the next after those 4 to 5 months, that next section of time is learning how to tune and to gain more precise adjustments to their gait. And a lot of that comes through sensory motor integration that develops through experience and through age, and specifically the timing and the responses of the postural control from the external perturbations or stimulus. So again, in those first 5 months, we see a lot of foot flat contact or toe heel initial contact with gait. After those first 5 months, approximately 70% of the footfalls are initial heel contact. So again, in those first 5 months of walking, we don't expect to see, knee extension, hip extension, initial contact with the heel. But by 5 months of walking experience, we expect to see that approximately 70% of their footfalls are initial heel contact. So in toddlers between 12 and 19 months old, this study found that they averaged almost 2,400 steps per hour. That's over 7 football fields, and they fell 17 times per hour. I can tell you that if I did that and I fell 17 times an hour doing something, I would probably quit. I would sit down and say I'm done. And I think this also speaks to the resiliency and the innate sense to get up and to get walking of our kids, and we want to promote that and help to keep that moving and help them feel successful in their experiences with walking. So they did find, though, that beginning walkers traveled farther faster than experienced crawlers, but the fall rates were very similar. So this kind of shows that we have an increased efficiency in our walkers without an increase in cost. So again, that motivation to get up and walking, I can go farther faster and I'm not going to fall anymore, shows that we want to get up and get moving. So if we take that almost 2,400 steps per hour and 17 falls, and say an average day is 6 hours of activity for these kids between 12 and 19 months. So half their waking hours are active. That is 14,000 steps, 46 football fields, and 100 falls. Again, this is massed practice. The thing with this practice, it can either be good or it can be bad. If it's bad, we're going to get bad results, right? Bad input equals bad output. We want to make sure that the practice that they're getting at this early age of walking is good, positive practice, that we're not developing compensations, that we have a good stable base of support, good lateral weight shifts, developing postural control, all of those things. We want to make sure that that input and that massed practice that we're getting of 14,000 steps a day, I mean, I don't do that. That's a goal for a lot of us here at the office is to get that many steps. So we want to make sure that that practice is good. So this is a video clip of a little guy who is typically developing. This is at 3 weeks of walking experience. So he's almost 11 months old in this clip. And we can see he has a resiliency to get up and walk. He will fall and fall and fall and fall as he's learning to kind of get up and to get moving and control his weight patterns. You can see him shifting his weight back and forth. He's going to fall, try to get up, fall again. Again, same thing, try to get up. He starts moving, and at the end of the walk, he's going to fall again. And he will do this all day long. He is so busy. And this is in 10 seconds, and we've fallen 4 or 5 times. So this, again, shows that, all this mass practice, he's learning and kind of building that repertoire of where do I need to keep my center of mass in order for me to be successful to get up and to get walking and to not fall. So this is the same kid. This is actually at 1 week of walking experience. And I just want to show you this because this is the way that he crawls. He crawled like this from the beginning. We have his right hip is externally rotated and his knee is flexed. So he's using that right foot and not actually crawling in a typical quadruped position. And his entire family, extended family, everybody, whenever they saw him crawl, thought it was the cutest thing ever. But what we didn't realize was this was actually his use history and what he was mapping in his practice that he was getting over and over and over again in crawling. And now that we watch this back, if I say, this is how he crawled, how should I expect his walking to look like? Right? Should I expect that right foot to be in a more neutral position? Should I expect that right hip to be in a more neutral position? And I shouldn't, right? Because this is what he's practiced and what kind of that repertoire that he's built, this is how he's going to walk. So this is him now walking that same day. We can see his pelvis is turned towards the right. We've got external, his right foot is externally rotated and everything is kind of shifted to that right side. So what this is going to take is massed practice of walking and learning how to swing that right hip through and to kind of rotate everything back to be in a more neutral position. But had we caught this when he was crawling, we may have been able to eliminate him walking this way. This is him again at 6 weeks of walking experience. So we can see he's still crawling that way. This is how he still gets around most of the time. But when he is up and walking, we still see that external rotation on the right. So that's going to take some time to kind of work that out. This is him again at 5 months. Most of that external rotation has kind of worked itself out after 5 months. We still see remnants of it here and there. In the rare instance that he does now crawl in a typical quadruped position. He's gotten rid of that right external rotation and flexion. So on the gait mat, we calculated velocity and cadence. We can see velocity has increased each and every test that we did at 1 week, 3 weeks, 6 weeks, and 5 months of walking experience. Cadence has also increased. This is really interesting. So step length, we can see at week 1, his right step length was significantly lower than his left. So as he was externally rotated, that right step was barely making up any distance. He was leading with his left. Over time, that gap has closed each and every test that we have done. We're at 5 months of walking experience is almost closed. His base of support has decreased every single walk, as has his time spent in double support. Also, you can see there in the bottom right, toe angle has decreased significantly as well, with the biggest jump being from that 6 week of walking experience to 5 months. We're pretty symmetrical now in toe angle. So as we start to talk about toddler gait and the development of gait from toddlerhood, we start to get a transition from a wide base, high step gait to a more narrow base, heel toe gait pattern with an arm swing, beginning around 6 months of walking experience. And then between 6 and 8 months, we should see shoulder and pelvic disassociation. So what that means is if as I take a step forward, my shoulders are going to turn towards my right, my pelvis is going to turn towards my left. So I start to get that disassociation and move in a more articulated strategy versus the en bloc strategy. So we should start to see that around 8 months of walking experience. So this is a video of Camden. He is 2.5 years old, 29 months. He's been walking for 14 months in this clip. So walking at 15 months is pretty typical, a little bit on the late side, but within normal developmental range. But even now at 2.5, he has a very immature gait pattern. He has no arm swing, no shoulder pelvic disassociation. He's not running or jumping yet. So this is somebody that we definitely want to address. Look at his foot and ankle. He's got some significant pronation. So we're going to address his foot and ankle, and then over time kind of watch him. And if we don't start to see some of those gait maturation components that we want to see, we'll potentially take a look at addressing his pelvis with some sort of a compression garment or something to give him some more input at his pelvis. But we'll start at his foot and ankle, and we'll see where we've come in 6 months a little bit later. So around 3 years, we have more adult-like stance-based kinematics, a narrower base. Muscle activation patterns are similar to that of adult. We have better control of our center of mass. Between 3 and 8 years, foot bone ossification is starting to solidify. Our hips gain full extension range of motion, so we have an increased step length because of that. And then arch is starting to develop and mature between this 3 to 8 years old. So what do we need to do? So we've talked about use history and all of the practice that a typical child will get. We need good repetition. Again, good in equals good out, bad in equals bad out. I've kind of harped on it, but practice and getting good, consistent practice is what's really important for the kids that we treat. So this is a video of a little guy who is 20 months old. He's been walking for 4 months. So we can see that he has a lack of lateral weight shifts. He's very out of control. The movements that he has are not just variability, but they're what makes sense to him in order to keep his center of mass within his base of support and to stay on his feet. All of the upper extremity movements that we see as he turns, all of those extra movements that we see are him just trying to stay stable. So what would happen if we don't treat him? He's already walking, without SMOs. He'll probably continue to progress in his gross motor skills, but what will those look like? Will they look good or will they look bad? I think if we were to let him continue to progress, we're going to start to look like this. So this is a little girl who is 2.5. She's been walking for 8 months. Again, we don't see a more mature gait pattern that we should see with 8 months of walking experience. We don't see arm swing. She has a high guard. We don't see any shoulder pelvic disassociation. And this is another little guy running. His mom says that he will run and run and run and run. He does not get tired. He doesn't like to sit. He doesn't like to stand. So this is what he does. And he's running, right? I mean, you know, at the end of the day, he's getting from point A to point B and doing what he wants to do. But if we look at this run, there are so many things going on. All these extra arm motions, the head is turning. And again, this is not good variability. This is what he's learned. This is what makes sense to him. You know, and kind of poor learning, poor weight shifts, and poor postural control development. So again, you know, if we don't address these at a beginning age, this is probably what we're going to start to see. So yes, they're doing the skill, but the quality of that skill is going to suffer. So this is Ethan. He is 7 years old. He has had no previous orthotic treatment. He came into the office complaining of pain, fatigue, and just overall clumsiness. And again, he's walking, he's functional. You know, if you go to talk to a physician, they'd say that he's fine. You know, we don't need to address anything, but you know, his quality of life is suffering due to his poor foot and ankle position and the posturing that he's developed over time. So his major issue is significant pronation. So this is what happens if we don't start to address these issues early on and believe that they will outgrow them and that they will accomplish skills just the same if we don't treat. They're going to be 7 and complaining of pain and not being able to play with their friends because they can't keep up, and sitting inside because they're embarrassed to play with their friends. So this is really important as to why we want to address early. So as we've talked about this, we've talked about significant pronation, and we understand that pronation is normal in gait. Pronation is normal in toddlers. We should start to see the amount of calcaneal eversion decrease as they get older until around 7, when we like to see more vertical calcaneus. But in stance phase, the calcaneus, we supinate, pronate, and then supinate again. And we'll see that subtalar neutral is not a static position. It's not a goal that we want to set our kids in. It is actually, it's a moment in time that we pass through twice each stance phase. So what we want to do is provide solutions that are going to allow normal motions in and out of midline, provide that stability within a normal range of motion, but let them pronate and let them supinate and not try to lock them up into subtalar neutral. So what does addressing our deficits do? When we see those deficits and we address them, what kind of positive changes are we going to see? Okay, so this is that little guy that we saw earlier who kind of had that drunken sailor walk. With the SMOs, first of all, his shoes are way too big that we see in week 1, which I think is another point in that we want to make sure that the shoes are an appropriate size for the child and that they're not walking around in shoes that are too big. But at week 2, we start to see his arms drop. He's moving more naturally and more fluid. And then by week 4, his gait pattern looks phenomenal. The difference between day 1 and week 2, we see that big change that his arms have dropped. And the change between week 2 and week 4, again, is significant in the fact that he's now, as he turns, he's able to control his center of mass within his base of support and keep that tight radius of a turn, whereas in week 1, when he wanted to turn, he was kind of all over the place. He was stumbling a little bit. So this is a really positive change in just a month that we've seen with the Surestep SMOs. So this one is Camden. He's now been wearing the SMOs for 6 months. He's now running and jumping. So in 6 months, we've gained a better gait pattern, but also running and jumping, and they're working on stairs at this point. At month 6, you know, we start to see more arm swing. His arms have dropped from that high guard that we saw in week 1, dropping down a little bit farther at month 6. Starting to see some arm swing, some shoulder and pelvic disassociation. Again, we'll continue to track him, and over the next, 3 to 6 months, we want to see a clear definition of some of that pelvic and shoulder disassociation. So these are some still frames that we pulled out from his day 1 and month 6 walk. At initial contact, you can see his arms, he holds them in a fist. They're kept a little bit higher, kind of in that high guard position. At month 6, his arms are definitely more relaxed. His hands are open. At loading response, we can see that left arm is starting to swing back, whereas day one, he still kept it tight and flexed. And then we get even more arm swing as he transitions through mid stance and then into initial contact on the opposite side. So again, with these stills, you can really see the difference that we're getting not only at the foot and ankle, but also in his trunk and upper extremities as well, which this is going to help reduce the energy expenditure that he's doing walking. As it's a more fluid motion and he's using his arms for momentum, he's using less energy to get through every step, which means we can start to concentrate on bigger and better skills such as that running and jumping and doing stairs. All right, so this is probably one of my favorite proprioception and postural control videos. So this little girl, I believe she was 3 years old. In this clip, she's not wearing anything on her foot or ankle or any compression garments. And bless her heart, she will try and try and try to stand up. At this point, the wall that we have in this building was curved, and I think she's going, to try to walk up it backwards. She has no sense or no clue as to where she is in space, but she wants to get up. So she has that drive and that motivation to get up and walking. And I think if it weren't for Mom stepping in here, she would be doing handstands and rolling over. So we put SMOs and SPIO vest or compression garment on her. And not only did her gait pattern improve, but watch her try to stand up here. So she takes a couple of tries to get up, but she gets up and she goes. And she did this over and over again. So just a little bit of foot and ankle sensory input, correcting her foot and ankle position, and then also the SPIO compression garment that really gave a lot of proprioceptive and sensory input into her pelvis and her trunk. We gave her the ability to find herself and to get up and to stand from the middle of the floor, which she was unable to do when she was barefoot. So this example is Ethan, the one that we saw that was 7, complained of pain and fatigue and clumsiness. So barefoot, he is unable to maintain single limb stance for much longer than like 4 or 5 seconds on the right side and just a couple seconds on the left. And so what we can see in these videos, barefoot single limb stance, is that he's using a lot of compensatory movements of his upper extremity, using the opposite limb to kind of help propel him and to maintain stability for that short period of time. With the SMOs, his time and stance that he was able to maintain in single limb stance increased significantly. The amount and the degree of compensations that we saw from his trunk and his upper extremity also decreased significantly. And that happened on both the right and the left side. So here we'll watch the comparison videos. Again, the top video is him barefoot, the bottom is with big shot SMOs. The difference in the compensatory movements and the upper extremity and trunk movements that we see is significant. That has reduced. He's actually able to pronate and supinate in the Surestep big shot SMOs, whereas in the barefoot condition, he is significantly pronated the entire time. He doesn't have the ability to pull himself out of that position and actually supinate in order to maintain control. So same thing on the left side. That time spent in single limb stance increased significantly. So barefoot on the left-hand side, he was only able to stand for 2.2 seconds. With the SMOs, we were able to get 7.5 seconds of single limb stance. And on the right-hand side, barefoot was 4.9, increased to 8.1 seconds. So that time increase was over a 50% increase bilaterally that he was able to stand. His mean center of pressure velocity decreased bilaterally. Again, so we're able to control that center of pressure on his foot within a smaller range. And then step length increased and velocity increased. So that single limb stance, while it may not seem like he's going to go out and practice single limb stances all the time, that's really important in that lateral stability and gait initiation. And then throughout gait, I need him to be able to do a single limb stance for a short period of time as he swings through on the other limb. So what this is going to do for him is to decrease energy expenditure, let him be able to play with his friends, and compete and participate in his life. And in fact, when he came back in for a follow-up, that's what his mom reported, is that his pain decreased, which for a 7-year-old is huge. He's also able to play with his friends and be active where he wasn't before. So, a simple piece of plastic, made out of the right plastic, trimmed right, under the right fitting guidelines, made a huge difference in this child's life. So this paper wasn't actually published. It was a poster presentation that was done in 1994, but I feel like the implications of this presentation were really big. So these guys took 2 10-year-old boys. One was typically developing, one had spastic cerebral palsy. They had them each walk 2 different ways. So the first way for the typically developing child was self-selected, and the second way was with an anterior center of mass. They did gastroc EMG. What they found when he was typically walking at a typical pace or typical weight line was that his gastroc was on at appropriate times, but when he walked with a more anterior center of mass, his gastroc was on almost the entire gait cycle. It was on really strong in early stance, and then even through swing phase. So they had the 10-year-old boy with diplegic cerebral palsy walk typically at a self-selected pace and position, and then with a less anterior center of mass. So they had done some gait training with him to get his center of mass more posterior. So again, you can see his EMG at self-selected was on for longer than it should, throughout the entire stance phase, but then also the little blip in late swing. And then when he walked with a less anterior center of mass, it was on at more appropriate times. So the timing of muscle firings may actually be part of where our center of mass is and where we're walking. It may not be necessarily a property of the muscle itself or that spasticity, but we can affect some of those gait patterns with controlling center of mass, which I think is a really big thing for some of our kids that we're either overbracing or selecting surgery or other procedures, that if we can just change their center of mass and teach them better postural control, better weight shifts, that we can actually have an effect on their gait. So what are our orthotic goals? Is it walking? I have a lot of parents that come into the office, and say, my kid's walking now, I don't need these anymore. And that's not our end goal. So I think we need to be prepared to talk to our parents and our physicians that, the end goal is not walking. We want to help develop good postural strategies, build this repertoire of motor control and planning, but then beyond walking, as we talked about, walking continues to develop for a long time. Once we're walking, that's not the end game. So we want to improve functional range of motion, improve proprioception, and that happens through compression, providing input to joint receptors, provide optimal alignment, whether that's correcting pronation or supination, but providing that optimal alignment within a healthy range of motion. Provide optimal variability in choices of motor planning. So whether that is introducing variability in their motor planning or reducing the amount of variability that we're seeing, we need to provide and determine what that optimal variability is. We need to provide a stable base of support and opportunity for good practice. So how do we accomplish this? First is early referrals. Right? We don't want this kind of bad mapping to get too far to where it's going to take a lot to correct it. That's why early intervention is very, very important. Through orthotics, so SMOs, AFOs, using compression to help facilitate this gait development, and then through just kind of playing with weight lines. So there are a lot of things we can do with wedging and with the orthoses themselves to address weight lines. And then therapy. There are a lot of therapy solutions and thoughts and theories. And I'm not a therapist, so I'm not one to say one is right versus another, but those are just some of the therapy things that I know of that are out there. So questions to ask when we do our evaluations. First is, where is our weight line? Is it anterior, is it posterior? What's the pelvis look like? Do we have adequate range of motion? Do we have adequate control of the pelvis? What's the foot and ankle or that base look like? Is it pronated? Is it supinated? Do we need to correct it? Have there been adequate development of postural control and spatial organizations? Can they laterally weight shift? Are they comfortable and stable there? And then do we need to add variability or constrain variability with our treatments? So Surestep works really, really well in developing postural control, spatial organization, and the development of gait. It provides stability in and out of midline. So the Surestep SMO will help facilitate that pronation and supination without getting into abnormal positions. It allows a child to build that repertoire of movement patterns and increase variability to help them select an appropriate movement. And it provides a tool for them to learn. It's not something they're going to depend on. It uses circumferential compression to improve the somatosensory input. It improves lower extremity alignment, providing a good base of support and improving weight lines and the ability to laterally weight shift. But what we need out of it is consistent wear time. To get that consistent practice that those kids are getting day in and day out, that they're getting that massed practice, we need that consistent wear. Okay, and this now concludes section 1 of 5 of the building blocks of gait development. And hopefully you've understood why Surestep works and helps facilitate gait development. If you aren't fully familiar with the Surestep product line and how the concepts and theories behind Surestep, be sure to check out our website for the webinars, for live courses, and for more on-demand courses.